Data Skeptic features interviews with experts on topics related to data science, all through the eye of scientific skepticism.
Chris Stucchio is a former high-frequency trader, physicist, startup founder, and bodyguard. He's currently a gambler and the director of data science at Wingify. He's a strong believer in automated reasoning, formal methods, and the power of computers to liberate us from the tyranny of humans making decisions. You might like his blog at chrisstucchio.com, which will be in the show notes. Chris, welcome to Data Skeptic.
Hey, how's it going?
Very good. Happy to have you here. So I caught your talk, Multiple Comparisons, which has the subtitle I like the most, Make Your Boss Happy with False Positives, Guarenteed. And I thought it'd be really interesting to explore some of the topics you covered there about how people can abuse their data. But before we get into that, I thought maybe it might be good to start out with the discussion of sort of the proper ways of doing these sorts of things. Maybe could you give us a definition of what conversion rate optimization is to you?
Okay, so conversion rate optimization is typically done on the web. So you're running a website. Let's say you're selling beer on the internet. You have some cohort, let's say 20,000 people visited your site. You want each of these people to purchase beer, but not everyone's going to actually purchase beer via your website. Some of them get bored. Some of them don't trust you. There's various reasons why some of them just can't figure out your checkout form. There's various reasons why people are not buying beer on your site. Some do, however. The number of people who buy beer divided by the number of people who visit your site, that's your conversion rate. It's basically the fraction of visitors who actually purchase.
Somewhere between 0 and 100, I presume?
One would hope. So conversion rate optimization is the process of making changes to your site to increase this number. So typically it'll be things like making the user experience, coming up with a compelling product image, that kind of a thing.
How do you know the breadth of options you might want to test for? I could think of anything from colors to font size to page layout. It seems sort of endless.
So generally speaking, the best way to do this is to actually try to do some user research. So for instance, you may want to do things like ask customers or a focus group what they think of your site. And then if they say something like it's hard to use, that'll give you different ideas of what to change than if they say you seem really shady. So that's user research. You can also watch visitor behavior. Like here's the thing. A lot of times people aren't going to say something mean like your site's really hard to use. But if you watch them going through the checkout form, then you might observe that it takes them 7 minutes to actually enter a credit card. For instance, at Wingify, one of our products is visitor recording. So you can actually watch people out in the wild and watch what they do. And sometimes what they do is going to surprise you. They'll just not be going through the flow you wanted them to or you expected. Like here's a concrete example. You see people hunting around a page. They're clicking everywhere. They're trying really hard to actually purchase your product, but they're just not finding that checkout button. That gives you sort of the hint that you should make that checkout button big, red, point arrows at it, flash, etc. Whereas people are jumping away really fast, maybe they just don't trust you that much or your product offering doesn't seem so compelling, so that's the thing you need to change.
Yeah, I'm personally frustrated when I'm at a site and I'm trying to give them money and they're making that difficult for some reason. Can you tell me a little bit about some of the products and services Wingify has that can help people to do site optimization of this nature?
So our primary product is the A/B testing product. So once you have an idea, you can use our product to run an A/B test, which is to say you show half of your visitors the new modified version, you show the other half of the visitors the old version. And then we'll measure the conversion rate on each version of the page, tell you which one has a higher conversion rate.
And then you were mentioning there that setting up kind of a proper control and test group. I've also seen people who have just rolled out a blanket of changes. Like let's say we want to color a button, so you want to try 5 different colors all at once. How important is it to keep that control group, that original example to compare against?
So ultimately, in principle, it's not important. What's important is that of the things you're actively considering choosing, you include them. So if you're 100% certain you're not going to run the control, then go ahead, exclude it. It doesn't matter. Whereas if you have a site that's working for you and you want to know, should I make this change to an already good site, then the question is are my changes actually better than what I already have? I mean, look, there's some websites that are just broken, they're a disaster, they're terrible, and you know for certain you have to get rid of them. If that's the case, don't bother including it in the control since you know it's gone anyway.
Good point. So when it comes to the A/B tests you're going to conduct, I've seen some A/B tests where there's an obvious winner. Something is just, 50% better. It went from broken to fixed. But a lot of times these changes are subtle and might be in the single or fractional digits of a percent improvement. And then, of course, we've got to use statistics to do a test. Generally, I see people using this alpha value of 0.05. Can you share your perspective on what that is and how a non-statistician should interpret that value?
So that's a tricky question. For the most part, I have not successfully explained that number to non-statisticians. Mm-hmm. I'll tell you what that number means. The number means the following. Imagine hypothetically you weren't running an A-B test. You're actually running an AA test, which means that you have two groups, A and green A, like red A and green A, where the web page is exactly the same. So you just ran a real A-B test, which had, 5,000 samples in each variation. 5,000 samples for control, 5,000 samples for the variation. Now, what the p-value tells you is, imagine you actually ran an AA test where both web pages were identical. The p-value is the probability of seeing a result at least as extreme as what you just saw. If you observed that B was, 2.5% better than A, and that this 2.5% had, let's say, a 5% p-value, then essentially, had you run the AA test, the odds of seeing a result like this, or maybe more extreme, like 6 or 7%, would have been only 5%. It's definitely a mouthful, and it's kind of backwards from what you actually want.
Yeah, I think you were right earlier in saying it is hard to explain it to non-statisticians. I had someone once tell me that by the time they finished explaining it, the person's a qualified statistician.
Yeah, so it's tricky because what people actually want is the probability that B is better than A. Mm-hmm. And unfortunately, the frequentist p-value is only indirectly related to that. So it's certainly the case that a smaller p-value means it's more likely to be true, but nevertheless, a 5% p-value doesn't mean a 95% chance of that thing being true.
So there's a famous quote I think everyone knows. I had to Google its origin. It's by a man named William Edward Hickson, and it says, "If at first you don't succeed, try again." So perhaps if I was doing the A-B test you described of the red A and the green A, and I didn't find any effect, I accepted the null hypothesis, maybe I wasn't looking at the right group. Perhaps I should segment that by age or gender or income or any of the other variables I have. After all, we've got really fast computers that can slice and dice this whole data set. Why shouldn't I just test every possible segment I can conceive of?
So here's where it gets difficult. Had you been running a classical AA test, there was a 5% chance of seeing a result at least this crazy. Remember, this is 5% of that result. So now suppose you slice and dice your data. So now you have the data sliced two ways. If you run that exact same test, you'll have a 5% chance of an error in group A, and then another 5% chance of an error in group B. So now the odds of you finding something interesting in one of these groups is now 10%. Mm-hmm. And then if you want to slice and dice it further, it'll go up 15, 20, 25%, depending on how many different ways you slice it. So essentially the issue with slicing is that each time you run the test, there's a chance you're making an error. And if you do it too many times, that chance just goes up and up.
Seems like eventually, I would almost certainly be able to find something. So I know common techniques to deal with that situation might be to adjust that p-value with something like the Bonferroni or the SIDAC correction. What's your perspective on using techniques like that?
So let me explain basically what Bonferroni is.
Sure, that'd be great.
So let's say you have a p-value cutoff of 5%. Let's say you were running 10 tests. You now have, roughly speaking, a 50% chance of seeing a false positive in at least one of these tests. What Bonferroni does is says, let's start with a lower p-value cutoff. So instead of having a 5% cutoff, Bonferroni says, let's have a 0.5% cutoff. Then if you add this 0.5% chance of an error across 10 tests, it adds up to 5%. Now, the odds of having a false positive in one of the tests adds up to 5 because any individual test has only a 0.5% chance. So the problem with this is that to get a 0.5% chance of having a false positive, you then needed to use a lot more samples per variation. Let's say it took you 5,000 samples per variation to run a two-way test. Now, if you wanted to run 5 two-way tests, instead of needing 10,000 samples, you need... So previously, if you ran one two-way test, A versus B, you needed 10,000, 5,000 for A, 5,000 for B. Now, if you're running 5 of these, A versus B, A versus C, all the way up to A versus F, if you were to just do things naively, without running Bonferroni, you would need 30,000 samples, which is to say you've got 6 groups, each of which needs 5,000. However, because you're imposing this sharper p-value cutoff of 0.5 instead of 5%, you now need a lot more samples per variation. Instead of being 5,000, it's more like 8,000 or something of that nature. So now instead of needing 6 times 5,000 samples, you suddenly need 6 times 8,000. That's 48,000, which is obviously a lot higher. So if you're Google, I highly recommend you do this kind of thing. But lots of other people don't have quite that scale of traffic where 48,000 people is just something you can throw away on a whim. Therefore, if you're one of those people, then you got to be a little smarter about it.
In that case where I'm testing, let's say, the color of a button, I might, in my experiment, need to accept the null hypothesis. And if I've maybe listened to all the advice you've just given, I know not to go in there and necessarily just segment my data until I found something. What about declaring the button color a failure and conducting a brand new analysis on a new data set that tests, let's say, fonts this time, or size, or spacing, or something like that? Do you think I'm still running into the possibility of too many comparisons, even when I generate an entirely new experiment?
You're always running into that possibility. I mean, essentially, every time you run a test, assuming the null hypothesis were true, there's a 5% chance of an error. Each time you run a test, there's always a chance you're going to get erroneous results. Mm-hmm. I mean, this is an important thing to recognize with all testing programs. The goal is not to make the right decision every time. The goal is, in a sequence of 20 or 30 decisions, your goal is to choose the right one most of the time. Mm-hmm. I mean, put it this way. Let's say you had half false positive rate. Half of them were false positives and the other half were true positives. And you deployed all these variations. That would be a perfectly acceptable outcome. The reason is that the false positives aren't costing you money and the true positives are making you money. So ultimately, the goal is less to avoid false positives. That's not even possible. The goal is fundamentally to come up with a decision-making procedure that gets the right answer most of the time and just increases your money in the long run.
So I myself have been thinking a lot about network effects recently. A network effect meaning like how much the people in a system value it. So if we think of like Airbnb, on the day it launched and it had, let's say, the very first listing, that's not a very great site, probably a low conversion rate because all the visitors won't necessarily want that exact one offering they have. And at some point they hit a critical mass where now most of the time you probably might find what you're looking for. So there was, presumably, I don't know necessarily any insider information about Airbnb, but I would guess it ramped up and that the more available places to stay, the better the site became and the conversion rate was kind of rising. So if a site like that was doing an A/B test while they were growing, how do they be careful that they're measuring an actual improvement by, let's say, the size of that button, not just measuring that a rising tide lifts all ships?
So ultimately, a network effect of this sort, I mean, this is a tricky question.
Oh, absolutely.
And ultimately, I guess to set up a good experiment, you have to make stronger assumptions and just hope that the product manager who's coming up with these assumptions is both correct and not deluding himself and not PHacking. First of all, a rising tide in general is going to be okay. The rising tide of having just more selection in the market, that should affect A and B equally in principle. What will actually happen if you do this is that, let's say you've made a change that causes this rising tide. You're actually going to undercount the effects of it in a test like this. Let's say you make a change that causes listings to go up. Listings will go up in both version A and in version B. Now, because they've gone up on both sides, A is seeing an increase because of B. So therefore, the difference between A and B is going to be a lot smaller than it otherwise would have been had these two systems been completely isolated. That actually just sort of makes the effects you see in the tests an underestimate of the true effect.
Makes sense. You mentioned a key term here I was hoping maybe you could define. What is p-hacking?
So p-hacking is the problem that arises when essentially humans get money from having a p-value less than 0.05, so therefore they play games until they get one. Here's one example. You've got scientists, they're studying the effect of some policy or some medical treatment. So they may look at 20 outcomes. Like they may look at whether this medicine reduces heart palpitations, whether it reduces, cardiac stress. I'm not a doctor, so I don't know many of these.
Sure.
And then across all of these, let's say 2 of them have a positive result. So then what they report is a study saying, guess what? This medicine, we tested it against these 2 effects, and it had positive effects on both of them. They don't actually report the fact that they ran the same test on 18 other categories and got nothing. Mm-hmm. So this kind of thing is p-hacking. So is setting up the methodology of a test in such a way that it gives an advantage to the version you want to win, that type of thing. Here's actually a big issue that was pretty prevalent in the CRO industry and actually still is. So a fun fact about this conversion rate optimization industry is that you have agencies. So these will be some experts in conversion rate optimization. So let's say I'm running a website. I'm really good at making chairs. I run a website to sell my chairs. I don't know a lot about conversion rate optimization, so I hire an agency.
Sure.
The agencies claim to be good at this. They'll typically have some model where if they get me X lift, I have to pay them Y money. Mm-hmm. So what this means is that when the agency can report me lift with a statistically significant p-value less than 0.05, then I have to pay them a certain amount of money. So it's in the agency's best interest to p-hack and do whatever they can to get me that number with that 5% p-value.
Yeah, I would be quite afraid myself if I were to hire such a consultant, because ultimately it's tough for someone to come back and say, well, I didn't make any improvement, now pay me a really big invoice I'm about to submit for all the time I spent. So it seems like there's a certain amount of pressure here to deliver results, and that people are very susceptible to p-hacking. From my feedback about the podcast, I know that a lot of my listeners, while I have some really technical, smart data scientists, I also have a lot of listeners that aren't necessarily that technical, but they're business consumers that leverage data scientists, maybe even would be hiring a consultant like that. How can someone who's in that position be appropriately skeptical of the results, or ask the right questions to determine if the consultant is p-hacked or not?
Ultimately, you have to be really careful, and you kind of have to understand at least the basics of statistical methodology yourself. So, for instance, when your consultant starts setting up a test for you, you ask them, like, before the test even starts, when are you going to end this and why? If they come to you halfway through, look, it's winning, we should declare a winner now. I know you want to deploy that because that winner looks great, but you have to say, no, run this to the end and let's do what we said at the beginning. Similarly, if the thing they gave you didn't win, but then they come back and say, well, look, it won for left-handed people on the West Coast on warm days. Ignoring the fact that you can't actually target that, you should say, but you didn't come to me early on and say it was going to win for this group. If you want to do segmentation, you really have to choose your segments before you start the test rather than at the end.
Yeah, good advice. So I will link to in the show notes the video of your talk at Crunch Conference 2015 that I really enjoyed. I think everyone should go check that out as a good complement to this interview. One of the techniques you showed there that is something I do a lot, and I appreciate that was included in your presentation, was to generate a random data set and then see how your methods work on it. Because by definition, if you generated it randomly, there should be no pattern. I was curious if it was for demonstrative purposes or if you find that that's a common approach in your typical workflow.
Well, that's for demonstrative purposes. So if you have some methodology, like here's an example. We have some CRO agency who doesn't actually follow the stats. They consider them informative, but also they apply their own human layers on top of that. Generating random data is a great way to test a methodology, whether that methodology is automated or involves humans. So then what you would do is you would show these humans randomly generated graphs where you know there's no result or you know there is a result, and see if their purported methodology actually works. So if you generate a bunch of data where you know there's no difference and they say, aha, we would declare a winner right here, you know that they're not being all that accurate.
So I know you've done a lot of work in high-frequency trading. So far, we've talked about A/B tests in this sort of, I don't even want to use the word simple because that makes it sound unvaluable. It's definitely valuable, but like test this color versus that color. I could see where these sorts of tests are much more complicated in the stock field because you're probably looking for certain stocks that correlate, that, you know, maybe all stocks in a certain industry rise and fall together, and you're looking for how one predicts the other. I could certainly do an exhaustive search of all possible pairs of all stocks in the stock market and look for a correlation, which would be wrong. How do I decide when to draw a line on what's an appropriate comparison in that context?
I mean, now you're getting into a really tricky case. The shares markets are a lot different than conversion rate optimization. First of all, in the CRO space, in almost all cases, I shouldn't say all, but in most cases, you get the actual ingredients to do a statistical test. You get independent, identically distributed random variables. Mm-hmm. What this means is that I'm browsing the website from my house, you're browsing the website from your house, so therefore what I do will not affect what you do. Mm-hmm. You can see that's a little bit broken in a case like Airbnb, but generally speaking, it's true. Mm-hmm. In the stock market, you don't have that. If I am purchasing Google, I believe, is included in SPY. So therefore, I've affected the share price of SPY. Now, SPY is a broad index of 500 or so securities. So therefore, what I just purchased now affects the market via other people purchasing those other securities. So you get this cascade effect. And this is why if you look at the stock market, there's a tremendous correlation between almost all securities. Essentially, the whole market moves up and down. Sometimes sectors move up and down. So essentially, you've given up independent, identically distributed. In the stock market, you basically have to be a lot smarter and have to have a real opinion about what's going on.
I know that was a tricky question, so I'll give you one more tricky one just so we've got a pair. When it comes to time series analysis, like looking at stock market data, how do you actually separate out a test and a training set? It seems like you're ultimately wanting to make some prediction about the stock, but that involves something that's sequential in nature, which is different from like a conversion optimization, which kind of has the filter to an endpoint. So how do you decide how to build a test and training set when you've got time series data?
The simple way to do it is take all the data up to a year ago, let's say. Maybe not a year ago, but ballpark. Then what you do is you run paper trading on that history. So you basically fit the model to that history. Sorry, you don't run paper trading on that. You fit you extract model parameters from that. Then you run the strategy against the current year. Strictly paper trading, and you see if you made money. Most places will then have a policy, and this depends on where you're trading, of course, but then they'll say, okay, after this, you now have a thing that you think works. So now we're going to do paper trading, but on the future instead. So you had a strategy, it seemed to work, you back-tested it against a year of data. Now they're going to run the strategy against new data over the next month. And if it makes paper money over the next month, then they'll say, okay, let's deploy this to production and we'll allocate a small amount of capital to it. So then you see if it actually works with real money. So you might be a trading desk at JP Morgan or Morgan Stanley, and you'll have this strategy running with, I don't know, $200,000, an amount of money that no one gives a shit about. So you check if it actually makes real money, do that for a couple of months, and then you slowly ramp up the amount of money in the strategy. This is one way to go. The other thing to do is you'll run stress tests against simulated data. So you'll consider various things that are kind of plausible but haven't actually happened yet. These are essentially sort of guesses about tail risk. You'll want to see if, I don't know, a 2018 recession will totally destroy your model. Third thing, so this is an economics concept, but it's tremendously relevant to trading. It's called the Lucas critique. So what the Lucas critique says in economics is, let's say you have a macro model. This macro model should be derivable from a micro model. When I say a macro model, I mean something like a model of unemployment and inflation in the broader economy. This should be derivable from some microeconomics model of employment for software engineers and employment for construction workers and purchase of homes and so on. So essentially what you want to determine is not only have I fit two graphs together, is there a reason why these graphs should fit together? And then you ask yourself, okay, if this reason is true, the model should be valid. What are circumstances when this reason will stop being true?
That's really insightful. So maybe I should bring it back to the conversion rate optimization topic we were touching on. How do you deal with the circumstance in which there may be multiple things changing on a site all at once, perhaps by design, in which case maybe we can talk about if that's a good design or not, or perhaps outside of the control of the person who's managing the actual A/B test?
So ultimately, these are all a judgment call. So if you're running two simultaneous tests, you should have compelling reasons to believe that they won't interact with each other. And ultimately, the value of your test is only as good as the value of that judgment. If you're really not sure, you should just delay them. Better to get solid results than to get wrong results quickly. Similarly, things outside of your control can totally tweak things. Possibly you started running a test, and then on Wednesday, you got featured on Oprah. Suddenly your traffic spiked. All your traffic for the entire week is the Oprah crowd on Wednesday. In this case, you just got to throw it away and start over because, fundamentally speaking, people referred to your website by Oprah on a Wednesday are not representative of your normal traffic. So in that case, you just got to accept that your test is ruined, but you got a lot of traffic, which is awesome. Start over, try again.
You'd mentioned earlier a key point when we were talking about setting standards with that consultant. So you asked them how long do they intend to run a test for? How do they know when it completes? It seems like time can play an important role in this. Take an e-commerce site, I suspect that weekend purchases are behaviorally different from weekday purchases. How do you balance those sorts of effects that might come in by day of week or perhaps even, day of the month?
So these kinds of things, ultimately, you should always be running your tests, like day of the week, you should always run your tests for an integer number of weeks. You start a test on Friday, you should end it exactly 7 days later. And if you don't have enough visitors at that time, then run it for one more week, even if you get enough visitors the next day. You're expending extra time, but the fact is you do need to have the same number of Fridays and Thursdays in the test.
One of the topics I wanted to ask you about was hierarchical models and how they can be applied in conversion rate optimization.
So hierarchical models are a fairly advanced technique. Most people, I would say, should probably not do them unless you really know what you're doing. Basically, what a hierarchical model does is it says essentially the following. I have a major effect. This could be variation A versus variation B. Now, I also have sub-effects that are caused by, let's say, 5 segment categories. So I may have, mobile, desktop, East Coast, West Coast, foreign. These might be my groups. They're overlapping groups, so I guess it would be mobile, foreign, desktop, foreign, and so on. So what I'm saying is the effect that variation A has or variation B has on one of these groups is driven by a general factor, which is specific only to A and B, and then a special factor, which is very specific to that group. You then impose a Bayesian prior that says most of the special factors are 0 or close to it. Then you'll typically run your Markov chain Monte Carlo. Most of the time, what these results will say is the groups don't matter. All there is this general effect. In the presence of strong evidence otherwise, they may show that the special effect actually dominates. So essentially, hierarchical models are another way of saying, go ahead and segment, but we're going to sort of correct for the multiple comparison issue with these segments. We're only going to accept that a segment has a real effect if there's strong evidence in favor of that, much stronger than we would accept if you were just looking for the general effect.
So it seems to me that while conversion rate optimization is an important critical step in any business, it's one that needs to be done with a lot of precision. I appreciate you sharing all your insights on common mistakes people can make and how to avoid them. I think doing proper CRO probably requires a good suite of tools. We touched earlier on some of the things Wingify has. Could you maybe regroup or go over any ones we didn't touch on? Mention how some of your company's products could help a person who wants to get involved in CRO?
Okay, well, I'll mention one thing we're doing, which is sort of an opinionated choice within the industry. And it's actually lost us quite a few agency customers, but we're sticking to it. So here's a very important fact. Let's say I ran an experiment 10 times and I had 1 success. The empirical conversion rate, that is to say what happened during the test, is a 10% conversion rate. Now, let's say I were to run the experiment 1 million more times. Are you absolutely certain that out of the next 1 million, I'm going to get exactly 100,000 successes? And the answer is, of course not. That would be crazy. Mm-hmm. It could easily be 120,000 or even 200,000. Mm-hmm. What I'm trying to distinguish here between is the empirical conversion rate of what happened during the test and the true conversion rate, which is what will happen if I run 1 million more experiments. The actual answer you want out of a test is the true conversion rate, not the empirical one. The empirical one is evidence that the true one is a certain number, but it's just evidence. It's not an exact number. So what this means is when you do the statistics, there is absolutely uncertainty in the true conversion rates, uncertainty in the lift of variation A versus B or whatever. So it's vitally important that your tool should report this uncertainty. Mm-hmm. So this was a very opinionated choice we made where in our tool, every place you would expect to see a number, let's say B was 10% better than A, we're actually giving you credible intervals, which are the Bayesian version of confidence intervals. We're saying B is between 0.5% and 27% better than A. This has actually kind of pissed off several of our agency customers because their clients don't want to see uncertainty. Their clients want to see an exact number, and it's actually making it a lot harder for them to PHack because sometimes agencies have been reporting scores when those actual numbers were like minus 10% to plus 11%, which is actually not much of a win. But the agency, before we were displaying that uncertainty, they were just going to the client and saying, here you go, good number, pay me now. So reporting of uncertainty is truly, in my view, the most important thing with any statistics you do.
Well, where can people follow you online? Well, of course, mention your blog, but Twitter, anywhere else people can keep up with you?
Yeah, I'm on Twitter. Mostly that's just tweeting when I write a blog post. Yeah, basically just my blog.
Sure. If you wouldn't mind, give us the URL and tell us a little bit about what people will find in your posts.
Sure. It's www.chrisstucchio.com. That's ChrisStucchio. And it's basically a mix of programming, mathematics, and whatever else I happen to find interesting at the time.
Excellent. Yeah, I'm a frequent reader and really enjoy it. So thanks for coming on the show.
Thanks for having me.
And until next time, I want to remind everyone to keep thinking skeptically of and with data.
For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.